All right, so we're going to get started. Who has heard of regular expressions before, but you haven't really written them? You've never written a regular expression, you think? Okay. Who has written a regular expression, but you don't really know what you were doing? Okay. Who's written regular expressions and you feel somewhat confident in your abilities? Okay. So we have a lot of different people sitting in the room right now. Regular expressions, they mean different things to different people, and your ability to write a regular expression, that means a different thing to different people. Who's ever written a positive look-ahead before? Okay. That's surprising. Maybe you can come teach those to us afterwards. So regular expressions, I'm going to mostly teach regular expressions themselves. In the process, we're going to learn about how regular expressions work in Python. So if you are already comfortable with regular expressions, this is going to draw out a little bit in the beginning here. If you've never seen regular expressions, this is going to be a little bit confusing, but it's because we have 3 hours, and I'm going to try to appease everyone in the room a little bit here. So everything that we're going to go through is on this first link, this first URL here, pycon2017.regex.training. We are not going to get through all of that material. There's probably about 4 hours of material there, and we have 3 hours. So we will get through quite a bit of it. There's also that SurveyMonkey link there. I'm going to try to remember to put that up again at the end. You can, after this tutorial, rate the tutorial, I believe, or fill out a survey about it on that link. So if you could all make sure you have internet, go to your web browser, get pycon2017.regex.training up in your browser. Also make sure you have Python installed. If you're having trouble getting to the website or getting Python installed, put up a red sticky. And so I've got 2 TAs for this tutorial. David and Steven are going to help me out here. None of us are regular expressions experts, because I don't know if there are any regular expressions experts outside of the few people who wrote the parser entrance for regular expressions in the various languages. But we can try to help in whatever ways we know how. Yep. Yes, that zip file is on the website. It's linked on the website as well. However, yes, so I emailed a zip file. Who has not downloaded that zip file yet? Okay. If you could go to the website, go to somewhere on the website. Ooh, the internet's not working well for me either. If you're having trouble with the internet, I've been told you can jump on PyCon 5G, and it should help out. However, I've also been told PyCon 5G is slower than the other one. So I don't know which one is the better one to be on. I'd try both of them out. I'm actually not getting any internet at all at the moment, which is exciting. I think I forgot my USB sticks. Does anyone have a USB stick you wouldn't mind me borrowing and passing around with a zip file on it? Okay, yeah. I did. I sent it out through the email. It was not an attachment, though. It was a link. So if you haven't downloaded at this point, you're going to have to deal with the internet here. So those exercises, during the first exercise break, hopefully by then we can get this sorted out. Before that point, I'm going to be coding. I'm going to be writing code, so I'm not going to use any slides. I'm going to be writing code. You can watch. If you'd like to follow along, you're welcome to type, but remember, this is all on the website, so you don't need to type anything. During the exercise breaks, that's your turn to type. I want you to be working through exercises, because if you don't do something hands-on, if you don't write something, you didn't learn anything. You just watched something happen. All right, so let's jump into this. Even though the internet doesn't work, hopefully it'll magically start working by the time the exercises start. Excellent. Could someone put the zip file on that USB stick and then pass it around the back of the room? Actually, David, could you help out with that? Thank you.
You were saying there is a link on the page?
There is a link on the website. It is, the problem is I don't remember where it is, and I can't access the website. Someone next to you might know where it is, but it is linked, I believe, under the exercises page. Yeah, under the exercises page. I believe it's on there. So We're going to back up a moment. I've been switching between Python 2 and Python 3 a lot lately because I teach Python, and companies want me to teach different things, so I'm going to be messing up that print function a lot. I'm in Python 3, I'm going to occasionally type a print statement. You're going to have to bear with me. What is going on here? Why didn't it type out the thing that I typed in? Yeah, that \n. That \n represents what? New line character. So in a lot of programming languages, \n is a new line character. In Python, if we want this to not be a new line character, there's a couple things we could do. We could double escape those backslashes, put 2 backslashes. We could also put an R before that string. What does R stand for? It stands for raw string. I want you to think of it as regular expression, though. This is a regular expression string. So it's a raw string because it ignores backslashes. The place that you'll see these used very often in Python is regular expressions, because in regular expressions, we use a lot of backslashes. So all of the regular expressions I type today, I'm going to try to remember to use that R there. All right, import RE. What does RE stand for? Regular expressions. This is an interactive tutorial, by the way, so feel free to shout things out when I ask questions. So I've got a greeting here. I'm going to search in this greeting for x. Notice I'm using an R there, even though I don't need to, because that is a regular expression. So I'm searching for x in greeting. It gives me nothing. It returns none, because there is no x in greeting. If I search for x in exit, I get this thing. If you're in Python 2, this thing is going to look a little different. It's not as helpful. In Python 3, it says we matched x. It is from character 1 to character 2. Now, this is a silly thing to do. How else could I do this in Python instead? Is there any way to do this without using regular expression? X in? Yeah. So in Python, we have substring matching. You don't need to use regular expressions most of the time. You are looking for something in something else when those somethings are strings in Python. So let's look at a case where regular expressions might actually be useful. So this takes me a while to write. If I were to look for every vowel in greeting, I'd have to type something like this. A regular expression could be handy in this case. We could say re.search AEIOU in greeting. We are looking for any of those characters. So regular expressions, we're going to see this as we go on today, they are an extremely difficult language to read. Regular expressions are a programming language. They are a programming language within another programming language, in this case Python. They're a programming language where every character tends to represent one statement. And you write all of your statements on one line of code without comments or white space. Who writes all of their Python code on one line without comments or white space? No one. It's actually impossible to write all your Python code on one line without comments or white space. Python doesn't allow you to. Regular expressions, we have to. We're going to see a way to write more readable regular expressions later, but in general, the reason they're so difficult to read is every character is a statement. All right, so this is a character class here. This goes by a lot of names. I'm going to call it a character class. The reason it goes by a lot of names is regular expressions are not a Python-specific thing. Perl, Java, JavaScript, Python, a lot of programming languages, in fact, almost every programming language has a regular expression parser. They're an old notion. In fact, they're a linguistic notion that was borrowed and taken into programming, which means we have different names for the same things, sometimes different symbols for the same things in different languages. Usually, if you learn regular expressions in the Python world, they're going to work the same everywhere else for the most part. All right, so we could also search for numbers. So we get none for rhythm because there's no digits in there. We get 1 for $100. Why do we get 1? Yeah, so this is matching a single character. the first character that it finds that matches 0 through 9, and it stops at that point. So search here, re.search, only matches the first thing. And this first thing in this case is a single character. So there's another way to write this. 0, 2, 9 gives us the same thing, a match of 1 there. And in fact, we aren't limited to just numbers for that 0 to 9. We can do that with letters. We can do it with lowercase letters, with uppercase letters. This one here is going to match nothing, and we can combine these. So this would match all alphanumeric digits. Actually, only the first alphanumeric digit. Yes, so that span there, if you're in Python 2, you're not going to see that 0, that 1. This is a Python 3 thing that it prints out of the REPL. You can get start, you can get end. That is where it starts matching and stops matching that character. And you notice that $100, it said 1, 2. Started at character 1, stopped at character 2. So these character classes, these can also be inverted. That caret I just put there, that is giving me $sign. It's giving me $sign because $sign is the only character in this string, or the first character in this string, that is not 0 to 9. So I mentioned this already. Regular expressions are dense. They're difficult to read. That caret, that is inverting this character class. It only works at the beginning. If I put 0 to 9 caret, it's matching 0 through 9 and a caret character. All right, so we're going to run through a lot of regular expression syntax really quickly. There is a cheat sheet on the website, so you do not need to write down notes on each of these things. If you look on the cheat sheet and you feel it isn't quite descriptive enough for something, feel free to take some notes, but you probably want to open up that cheat sheet when you're working through the exercises. So this gives me a regular expression object here. It's matching that last A, 3 to 4. What does that caret do? What did I say the caret does? Inverts a character class. So we were in those square brackets, which matches any one character in those square brackets. That caret there does something than this caret here. What does this one do? Yeah, this is matching an A only if it starts the string. So this is something we haven't seen before. This is strange for 2 reasons here. We've already seen caret, but it did something different than this caret. A caret inside of a character class at the very beginning inverts the character class. A caret at the beginning of a regular expression string outside of a character class matches the beginning of the string. So symbols in regular expressions are very context sensitive. This is one of those cases. Question mark is another one of those that we're going to see that's very context sensitive. This is weird for another reason, though. This caret here, what character is it matching? Is it matching a character? Yeah, it's not matching a particular character. It's matching a notion, the beginning of the string. So this is actually not matching a single character here, unlike that A and unlike that character class we saw before that matches a single character. This caret here is matching the space between characters. It's an anchor. So anchor is one of the words we use for this. This is anchoring itself to exclusively the beginning of the string. $sign here is the opposite of this. That's the end of the string. So there has to be an A and the end of the string. That's the only acceptable place to find this A. So this matches the single letter A. What would that match? Caret A, $sign. Just A. So the only acceptable string is A, which is a strange thing to search for. All right, any questions so far? Yep. It did not. So this order doesn't matter. I was about to say it doesn't matter at all. I believe it doesn't matter at all. There may be a performance reason it matters in terms of matching, but it is doing a match on all of those things. It could be 0 to 9, A to Z, A to Z. In fact, we could have put another 0 to 9 in here, or a 1 to 4, which is an odd thing for us to do. Other questions? All right, we're going to go through, yep. That's a great question. So for example, like this, it does not. So it's matching a single A, and the next thing that must follow that single A is the end of the string. So these regular expressions, we haven't gotten to this yet because we've only matched a single character so far. When you match multiple characters, it's matching them contiguously. So if I wanted to not match H-E-L-L or O, if I wanted to match that literal word with brackets around it, I can use backslashes. So this does not match here, while this does. The only thing this does match is a string that contains this. So open square bracket, close square bracket, caret. What else have we seen so far that's special? $, that's the last one I think we've seen so far. Those are meta characters. Those are characters that do not literally match what they mean in a regular expression, at least not in all cases. Whenever you see a meta character, you may want to backslash it just to make sure that you're matching it literally if you need to. And we're going to see a lot of meta characters. Regular expressions have quite a few of them. So for example, if we wanted to match a literal $, this doesn't work because you can't have a 1 after the end of the string. It's looking at the end of the string, 1, 0, 0, because it's not smart. We need a backslash there to match a literal $. What does this match? Yeah, any character, any single character. So it's matching H. Why is it matching H in particular? It's the first one it found. It's the first character that, or the first string that matched this regular expression. What does this match? Yeah, A, any single character, and a Z. Will this match? Who thinks it'll match? Who thinks it won't match? So it does match. It does match here because that space is seen as a character, even though it's white space. So it's an A, a space, and then a Z. What about this one? Who thinks this will match? Who thinks it won't match? Saw a lot fewer hands that time. Was that confusing? More confusing than the last one? Maybe it's because I'm asking trick questions. All right, I'll try to, I'll shuffle up the trick questions and non-trick questions. Yeah, so that 1, 4, it's starting matching at 1, ending matching at 4. So first I want to show this here. It does not match. It doesn't match because that A, there's nothing between the A and the Z. There has to be exactly one character. All right, so this 1, 4, start and end. If we were to slice this string from 1 to 4, we get the exact match there. So that's what that represents. There's actually another way to do that, group. We're going to look at that a little bit later. That is the way to get the actual string that it matched. So it matched exactly A space Z. Does that answer your question? Okay. Yep. Yes, exactly. That's the first. That's the first character that it found that started matching that regular expression. So regular expressions, they are a matching language. They don't just match single characters. They match a single substring, essentially. But they're not a straight substring match here. So this is describing a substring using a specific grammar, a regular grammar. And it is matching that grammar. It's starting that match at character 1, ending it at character 4. Yep. Right, so why does it end at 4? So this is a little bit odd. This is also behavior that's inherent to the slicing syntax in Python. So if you slice from 1 to 4, you get A to Z. If you slice from 1 to 1, you get empty string. So this is non-inclusive with that second one. It stops just before it. Yeah, so it's a slicing behavior. So you don't need to worry about those numbers. The thing that you actually want to worry about here is what it matched. It matched A space Z. That's the easier one. All right, so earlier you asked about A as the first character and last character, and it did not match Anna here. How could I write a regular expression that matched A, 2 characters, and an A? What could I type? Yep. Yeah, that matches there. Okay, how could I do A, any number of characters in an A? Yeah, so we haven't done this yet. So dot matches a single character. Dot, again, matches another single character. We want A dot A dot dot A, and any number of dots after that point. We want any of those to match. Asterisk is A and any number of characters. So asterisk here, this is a quantifier. It is modifying the thing that came before it. The thing that came before it matches any single character. This asterisk says the thing that came before me match that 0 or more times. So if you see AA, is that going to match? It will match. There are 0 characters in there. If we have ANA, that also matches. 2 N's, that matches. If we put 2 different characters in there, in fact, it also matches. It is any character it's matching there, 0 or more times. Questions about that? Yeah, why is it dot star? So this dot here, if instead I made it an N, it matches something different. AA works, ANA works, ANNA works, but if we put any other character in here, it doesn't work. So that star there is not a generic wildcard. It's a modifier. So it's taking the thing that came before it, which happens to be kind of a wildcardy thing, this period which matches any one character. That star is saying, do that thing any number of times, 0 or more. Yeah, this is a tricky part of regular expressions, because if you're working from the shell, that star is the equivalent of this dot star. You have more control in terms of what your wildcard means or what you're matching in regular expressions, because you've got both the dot and the star. Okay, so plus does something slightly different. If I could find the plus on my keyboard. There we go. It's funny how a slightly different angle of my keyboard ruins everything. Period plus, this is matching what? Anyone know? Yeah, so AA does not match here. All of those others do, though. So asterisk is 0 or more, plus is 1 or more. Okay, we've got one more thing I want to show you here real quick, and then we're going to jump into our first set of exercises. Who spells color this way? No one spells color this way. This way over here, this first one. We can't all be from the US. Okay. So some of you spell color this way, some of us spell color this way. If we wanted to match both of these, I could put a question mark there. So this is matching the thing that came before it, which happens to be a U here, that single character, 0 or 1 times. Now in this case, 0 or 1 is basically giving us an absence. It's either not there or it is there. And if it's there multiple times, doesn't match. Because that R has to follow a U that follows an O, and that U is optionally present there, but only once. Yep? The question mark and a plus sign. Yeah, in what? So what would you like me to type here? Right here? That gives me an error. Yeah, however, plus question mark does something, which is a little weird. We're going to talk about what that means later. That question mark here, I said before, question mark is another one of those characters that means different things in different contexts. These question marks mean 2 different things. We're going to talk about this question mark later. This is actually changing it to be non-greedy, which is a strange concept that is regular expression specific. So we're going to do exercises now. We're at validation exercises, so hopefully the internet works for you by now. If it does not, put up a red sticky and we'll try to work it out. The first exercise is has val. So if you have the zip file downloaded, I want to show you how to use it here. Unfortunately, I don't have easy access to it, so I'm going to go find that zip file and do what you're doing right now, getting that set up. Okay, so I've got my zip file here. You should be able to run Python, either Python 2 or Python 3, test.py has val, and it fails. Why does it fail? Yeah, this is failing because I haven't done anything here. So validation test.py has val knows to find some tests in there. If I open up validation.py, I will find a has val exercise. So we're in validation.py. Has val is integer, is fraction. So these functions, these are stub functions. Your job is to fill out these first few functions. Fill out these first few functions. So you're going to want to import RE, and you're going to want to do something here, probably return an re.search. And in fact, there's a hint on the website that if you convert this to a Boolean, you'll get a true or a false value. So this is not the answer to this problem, but it gives us a slightly different answer here. It gives us a little bit of feedback. So if you have any questions while you're working through these exercises, if what I just said is confusing, which it probably was because you haven't used this test.py file before, please put up a red sticky and David, Stephen, or I will come by and help you out. I really want you to work through these exercises today because you can watch me as much as you want, but working through these exercises while we're here together is going to be helpful for you to actually get up to speed learning how to write your own regular expressions so you don't have to go to Stack Overflow and copy paste them all the time. All right, any questions at all, put up a red sticky. So something I forgot to mention. We are practicing test-driven development. Who practices test-driven development already? You write tests before you write your code. Okay, so most of you don't, which is perfectly fine. We're practicing test-driven development, but I have done the hard part. The hard part of test-driven development is writing the tests. So I've written the tests. Your job is to write the code that gets the test to pass. So when I run this Python test.py hasval, the test runner that I've written is a little bit clever, maybe a little bit too clever. It goes into validation test.py, and it knows about this hasval tests, which run your hasval that you are implementing in validation and runs various tests against it. So if you want to see the test I'm running against your function, you can go in there. So it should say that rhythm doesn't have a val. So Y doesn't count as a val, E and I do, O does. So you can see those tests in validation test if you would like. So we're practicing TDD. I've written the test. Your job is to write the code now. If you have any questions about this, any questions at all, put up a red sticky. All right, I realize that was not very long. Hopefully you got at least some tests failing. You see some tests failing, maybe you've written a little bit of code. We're going to solve this first one together, though. All right, so what did you find for hasval that you thought might work but didn't seem to work? Did you type anything that you thought might work but didn't? Anyone want to volunteer anything that you found that didn't seem to work? Would it work if I typed AEIOU? What's that going to match? Specifically AEIOU. So it's going to match those characters sitting next to each other in a string. So that doesn't work. What could I do to get this to match? Put brackets around it. So this makes a character class. This is matching instead of 5 characters, it's matching a single character. So this is matching a single character, which is either an A, an E, an I, an O, or a U. All right, and that passes those tests. So these tests were not the most picky. They looked for lowercase vowels. They didn't actually expect searching for uppercase vowels. Or they didn't test that, rather. All right, any questions so far? Before we move on to the next section, which my browser is not loading. Bear with me a moment as I deal with the internet. All right, so how could I match a single digit? What could I type? How could I match any number of digits? Bracket 0 through 9, what is that going to match? A single digit, so one character. So this matches a single character because this character class here matches only one character. How can I get that to match one or more of these digits? Dot plus. Dot star. So this actually works here, but it works for that too. That isn't what we were looking for. 0, A, 0. Why is it matching the A? Like this? Remove this one? Oh, backslash D. Ah, yeah. So let's talk about backslash D. So this star here, this matches 0 or more. How could I make this 1 or more? Plus. So that is matching only 1, 0. So you just mentioned a shorthand for this. So 0 to 9 plus, this matches 1 or more digits. This is a pretty common thing to want to match. Digits are a frequent thing for us to want to match. So we have a shorthand. When I mentioned before that regular expressions use a lot of backslashes, this is one of those backslashes. Backslash D means something special when we're in regular expression land. It matches 0 to 9, exactly what we typed before. It's a shorthand for getting that character class. Oh, so when I used dot plus, it actually didn't work here. It didn't work because it matched 10A0. Because this dot plus here, it is matching 1 or more of dot, which is any character. Whereas this is matching 1 or more of that digit there. So this backslash D, this matches 1 or more digits. Actually, this matches a single digit if I just type backslash D. How can I match something that isn't a digit? How would I do this with a character class? Caret. Could I say caret backslash D? Might work. It does work. It's matching a non-digit there. So there's another way to do this. We capitalize the D. So regular expressions, they decided to make them hard to read by making lowercase d mean a different thing from uppercase d. Lowercase d matches a digit. When you uppercase something, it inverts its meaning, right? Like in English, right? When we uppercase words, their meaning just totally reverses. So uppercase d matches non-digits, lowercase d matches digits. Confusing, but that is the way regular expressions work. And this pattern is actually somewhat of a fortunate one because we're going to see this multiple times. Backslash W, this matches word characters. So this matches H. What will this match? Backslash W plus, what do you think? Will it match hello, just an H? Something else? So it matches all of hello. What about this one? Who thinks it's going to match hello? Who thinks it's going to match hello there? Who thinks it's going to match something else? So it stops at hello. So word characters don't include white space. They don't include spaces. The plus does mean one or more. So what it's doing here, it's looking for a word character. H is 1. It's looking for another one. E is 1. L is 1. L is 1. O is 1. Then when it gets to space, it stops. And this space, it has to be contiguous here. So it's kind of like if we had that $100 there, and we had A0. This found 100, stopped at the A, didn't find the next 0. It's asking for contiguous word characters, and that space doesn't have to be a word character. What about this one? Where do you think that'll stop? Who thinks it's going to match HELL? Who thinks it's going to match HELL0? Who thinks it's going to match something else? So just like in English, we're allowed to put digits in our words, which is a little bit odd. So HELL0 is a word character, or rather that 0 is a word character. So this \W, it doesn't necessarily do what you might expect. It's matching uppercase letters, lowercase letters, 0 to 9, and underscore. So that is a valid word. That entire string is a valid word in regular expression land. Who thinks this is a little bit odd? Yeah, so underscores and digits, we don't normally have them in words, but in regular expression land, \W matches underscores and digits. What does capital W do? What do you think? Non-words. What non-words might it find in here, if any? Space. That is actually the only non-word character in here. So \W finds space. What would this find? Nothing. So would I get a match object that's empty string? So I get no match object here. Asterisk gives me an empty string. Why does asterisk give me an empty string? 0 or more. 0 or more is always going to give you something back if it's a whole match that is 0 or more, because empty string matches 0 or more. Questions? Okay, so we've got lowercase d, uppercase D, lowercase w, uppercase W. Uppercase W is not a great way to match that space there. A better way would probably be to use a space. What other white space characters are there? New line, what else? Tab, any others? Another type of slash, a \R maybe? Yeah, maybe a vertical tab, because we type those all the time now. So there are a lot of different white space characters. If we want to match all white space characters, we can type \S. That is any type of white space character. So if I put a new line here, that would have matched as well if it got there. What is \S? Non-white space. So it's matching that H there. So lowercase d, capital D, lowercase w, capital W, lowercase s, capital S. So those are all shorthands for character classes. We could have typed those in manually using those square brackets. I'm going to show you a shorthand that is not equivalent to a character class. This \B here, \B hello, \B, it matches hello. It also matches hello here. It doesn't match hello there. What is it looking for? What's your guess? A break? What kind of break? White space maybe? So something, but here there's no white space. So maybe something, either the end of a string or white space, something like that. All right, let's try that out. see if maybe we can get any non-white space to work. So caret worked too. So it seems like there is some kind of break going on. It's not on white space though. Any other guesses? A boundary? What kind of boundary? For words? Okay, so maybe a non-word or a word character to a non-word character. Let's see. So caret is a non-word character. Underscore, is underscore a word character? It is, strangely. So is 0. So neither of those match. What about dash? It is a word character in English. It is not a word character in regular expressions. So yeah, this is a word boundary. So it is a break of sorts. It is a boundary. It's a word boundary. So this \b here, it is matching. This is actually another type of anchor. This is anchoring itself not to the beginning of the string, not to the end of the string, but to something that is the transition between non-word and word. So either we're moving from non-word dash to an H, that's perfectly fine, or we're moving from non-word beginning of the string to H, but we can't be moving from a word character to a word character. That does not match there. So \b is a way of enforcing word boundaries around the thing that you're matching. So this R I put before my string, this hasn't mattered up to now. It actually matters here. If I remove that R, it does not match anymore. Does anyone know what \b means when you don't have a raw string? Yeah, well, so it's actually not a literal B. It is a literal character, though. Or rather, I guess it's not a literal character. It is a character. It doesn't happen to be a literal B, though. It is \x08. I assume none of you have ASCII tables in your head. I know that I don't. It doesn't print. So this is a non-printable character. This \b is a backspace. This is an ASCII backspace character. Backspace is over the character that came before it and starts printing again. So you're probably never going to use a \b. They just get in the way when you're writing regular expressions. So always remember to put that R before your regular expression strings to make them raw strings. All right, any questions so far? How could I write a regular expression that matches US zip codes? At least this form of US zip codes. Curly brace. So we haven't looked at curly brace yet. If I wanted to do this manually, I could do either 0 to 9 or \d 1, 2, 3, 4, 5 times. And actually that's not quite right because that's looking for them anywhere in the string. I want to make sure the entire string is exactly that. So caret, it has to start at the beginning of the string, end at the end of the string. I'm validating that this is a zip code. Yeah, if we're doing correct zip codes, which I'm not going to go that far, but yeah, if I was doing actual correct zip codes, I would need to do a little bit further validation on here. I'm going to leave that up to you, though. This \d here, if I did \d plus, why is this wrong? Why doesn't this quite match the right zip codes? What would it match that it shouldn't, if anything? Yeah, zip code that's too long. Is there anything that it should match that it wouldn't? So in this case, I don't think there is. These are the two problems that you will always be battling with regular expressions. Matching things that you shouldn't match and not matching things that you should. There's a further meta battle in there of writing a regular expression that is readable but wrong and writing a regular expression that is correct but completely unreadable. You can't always write a readable regular expression that is also exactly what you're looking for. So often you make compromises and say, for example, I don't care about zip codes that start with a 0. I'm going to assume that maybe those, someone's not going to type those in. Or I don't care about zip codes that are over a certain number of characters. There's always a compromise that you're making in the world of regular expressions with correctness and readability. Okay, so if I don't want to type \d 5 times, I can do this. \d, open curly brace, 5, close curly brace. So this is matching exactly 5 digits. What do you think this will match? What's your guess? Will this match here? \w, that's a word character, 3, 5. We haven't talked about this comma. This does not match. 3 to 5? So what do you think? Will this match then? It does match. All right, let's try out 5. Will this match? Maybe less than 5? It's actually inclusive of 5 there. So unlike the slicing syntax, so it matches 3, it matches 4, it matches 5. Doesn't match that because that's 6. What would this match? What's your guess? 3 or more? So it matches mellow. Does not match high. So that is 3 or more. What does this plus do? What does it match? Would it match 0? Would it match 1? Yeah, so it is 1 or more. So it is equivalent to 1 comma. So you can think of the plus as the shorthand for curly brace 1 comma. What about asterisk? What is that equivalent to? Yeah, let's try that out, 0 comma. Yeah, that matches empty string there. So 0 comma is equivalent to the asterisk. 1 comma is equivalent to the plus. What would question mark be? 0 or 1. So that does match. What's going on there? Oh, that does match because it's 0. That makes sense. That matches. And that doesn't match. So question mark is 0 or 1. Asterisk is 0 comma. Plus is 1 comma. I believe that is on the cheat sheet. So if you don't remember that, feel free to reference the cheat sheet. Those curly braces there, this is the long notation for that asterisk and plus. If you need to do something more specific than those, reach for the curly braces. Those go by a lot of names. Those are repetitions, is how I think of them. Quantifiers are asterisk and plus. These are repetitions. Will this match anything? It will not. So why didn't that match this? Yeah, it's a case-sensitive match. We can alter the way the regular expression engine works in Python to make this match case-insensitive. It takes an optional third argument, which is a flag. re.ignore case tells the regular expression engine, whenever you see a case-sensitive letter, ignore it. Allow any cases. What will this match? Which letter? First one, because we stop at that first one. What do you think this will match, if anything? Also matches the first one. So this even is case insensitive for character classes, not just for literal characters. All right, we're going to look at one more flag here. If you already know regular expressions and you're bored at this point because you already knew all of this, hopefully at least this will be a takeaway for you here. This is the one thing I'd like you to remember out of this. Realistically, when you need to write a regular expression, normally you shouldn't write your own because you're probably going to write it wrong. You should go to Stack Overflow and look for the regular expression you're looking for, and if someone else has already written it and it is upvoted enough, hopefully it is correct. If it's not correct, then you just copy-pasted a wrong regular expression. But writing your own is something that should be reserved for niche use cases. US zip code, someone's written a regular expression for that. There's various ones out there. Something that's more domain specific to something that you're working on, that's when you need to write your own. Regardless of whether you're writing your own or copy-pasting someone else's, I want you to know about this next flag here. All right, so I'm going to copy-paste in a regular expression. This matches UUIDs. UUIDs are universally unique identifiers. They are made up of hexadecimal digits, and this is not actually specific enough. They're hexadecimal digits that have to be the right digits in the right places, but it matches roughly a UUID. So it is matching A to F, or a digit, 8 times. So 8 hexadecimal digits, a literal dash, 4 hexadecimal digits, a literal dash, another 4 digits, a dash, 4 digits, and 12 digits with a dash between them. Who finds this readable? So this is a really long line of code. Not only is it a long line of code, there are a lot of characters on this line. This is incredibly information dense because every character in a regular expression is a statement. So we've got our entire program here, our regular expression program, written on one line of code without white space or comments. If we want to add white space or comments, we can. So normally you might see someone try to break this up by doing something like this, splitting this up over multiple lines and using string concatenation to make this a little bit more readable. That works. It's a step in the right direction, but there is another way to do this. If you turn on verbose mode, and notice I'm using a pipe here. This is something you can look up in the documentation. If you need to use 2 flags, you need to use a pipe. This is a bitwise OR. Unfortunately, we're using bitwise flags here, which is a little bit confusing if you're not used to bitwise flags. Use an OR when you need multiple flags. If you have questions on that, feel free to ask me during the exercise break, the next one. So I'm going to make this a multi-line string. If you're new to Python, this is going to be a little confusing. These triple quotes here, they allow me to break this over multiple lines, this string here, and Python's not going to complain. Now I'm going to turn off verbose mode here. Will this match? Will this match a UUID? What do you think? Why wouldn't it match a UUID? What would it match instead, or need to match? Yeah, it's expecting new line characters. Also, it's expecting these indents. So we would have to have the beginning of a string, a new line character, a whole bunch of spaces, and then hexadecimal digit. A new line character, a whole bunch of spaces, and a dash. That's not what we're looking for. So I'm going to turn verbose mode back on. And we're going to actually try out this function. I'm going to generate a UUID real quick. Oh, my internet doesn't work. I'm just going to type a UUID. What did I do wrong? Oh, thank you. Something else wrong. That's 7. There we go. It's hard to make up UUIDs. So 8, 4, 4, 4, 12. This is a UUID. So if you have one takeaway from this tutorial, it is turn on verbose mode for all of your regular expressions, break them up over multiple lines, and more than that, comment them. With verbose mode on, if it finds a new line character that has an octothorpe character before it has a hash symbol before it will ignore that as if it was a comment, like in Python. So this should work just the same. All right, any questions about this? Who has seen verbose mode before? So if you are working in another programming language like Perl, for example, there might be an X mode. X mode is pretty much the same thing as verbose mode. In fact, you can say re.x there and it does the same thing in Python. I think we have a break at some point, but I don't remember when it is. Anyone remember what time the break is? Maybe there isn't a break. Yeah, I would guess halfway through too. Actually, let me check this. Well, it doesn't say on my little piece of paper here. So at some point, we may just take a break. I'll check how we're doing on time real quick. Yeah, if anyone finds out when the break is, feel free to let me know, because it'd be great to take it at the same time as all the other tutorials. So I flew from San Diego. And San Diego, like every other airport code, it is 3 characters, typically 3 uppercase alphabetic characters, so A through Z. How could I match an airport code in this sentence? What do you think? What regular expression might I try to start with? Can always improve it. Curly brace 3? Let's see. Yeah, so that matched it there. What if we typed like that? Is that an airport code? Will it match it? It'll match something. So what could we do to improve this? 3, 3? Let's try it. So that did the same thing there. What's the problem here? What is it matching? Yeah, so it's matching SAN, but it stops because it doesn't know that we don't want to keep matching. So after this, what could I put? \B, so word boundary. And before it too? Oh yeah, in fact, it matched A and O there. So it found a match, wasn't supposed to. So if I put a \B before it and after it, it requires that to be a whole word unto itself. Okay, so if we have a match, we have an arbitrary sentence, someone typed in, we found a match. Typically, we want to actually grab the thing that we found. So what we've been doing so far is mostly validation. We've been saying we want to make sure that something exactly matches a pattern. Here we're not validating, we're searching. We're looking for something inside of something else. So regular expressions can be used for validating that something matches a given structure or a given condition. They can be used for searching, popping something out of a string that you're looking for. They can also be used for substituting things, for replacing one thing with another. And that's the main use cases of regular expressions. So we're searching here. This match object, if I want to grab the actual SAN that we see out of it, I can type m.group, and we get the actual airport code that it matched. Ah, yeah, let's see. So if I say, for example, like that, yeah, what do you think m.group is going to give me? Just SAN. Why does it give me just SAN? Stops at the first one, yeah. So there is a way to get more that we haven't seen yet. We're going to talk about that, but this is a feature of re.search. This is fundamental to re.search. re.search stops at the first one. So groups here, let's talk about groups a little bit more. We have already made a search for a zip code. I think we did it this way. Is there any other way you can write a zip code? Yeah, you can put 4 digits at the end, so you could do a dash. So this is a more specific zip code. So the post office accepts either of these. You can be really specific, or you can be not very specific. They're fine with either way of writing zip codes at this point. How could I match this form of zip codes? What could I type? Yeah, so I need those 4 digits like this. Okay. So right, if I type this, will this match at this point? It doesn't match. How can I match either of these? So question mark, if I put a question mark here and a question mark here, that still doesn't match here. Why doesn't that match there? So this doesn't match here even though it should, and that's because this question mark actually changes the greediness. We're going to talk about that later. Question marks are confusing in regular expressions. I can use parentheses to group this. So far, every time we've used an asterisk, a plus, a question mark, curly braces, anything that modifies things that came before it, we've been modifying a single character. So A 1 or more times, any character 1 or more times, N 0 more times. This is taking this question mark and taking a group of characters and matching them 0 or 1 times. So it matches this, which is 0 times. It matches this, which is 1 time. Does it match this? So it doesn't match this because it did not see this whole string here, dash and 4 digits, 1 time, and it didn't see it 0 times. And it needs to see an end of the string after whatever it found. Oh, you mean afterwards? Like here? Let's try it. So it doesn't match. So the reason it doesn't match there is this is 0 or 1. Yeah, if I put an asterisk here, that'd be 0 more. Yep. All right, so these parentheses here, this is a group. These form a group. This group here, groups are a little bit odd because they're used for 2 different things. What we've just used it for here is grouping characters together to be modified, to be repeated or to be modified in some other way. Typically repetition is the way you modify either groups or individual characters. They can also be used for capturing something out of a string. So let's take a look at that. When I typed m.group before, it gave me the whole match. So in this case, it's matching all of that. I'm going to go back to this question mark here. im.group matches everything. I can pass to group a digit. If I say im.group 1, it's giving me this. What is this? It's the thing inside parentheses. So it is the first thing inside parentheses. So we're actually starting counting at 1 here. If I put in 0, it gives me the whole string. So 1, 0 represents the whole match. It's just like if I don't pass in anything. 1 represents the first group. So groups are capturing by default. So these groups are used for grouping to be modified. They're also used for pulling something out of the string to capture it. Any questions about this or about groups? Oh, yeah, so how would I get just the first part? So I could, if I wanted to, put parentheses around it. And then if I say im.group 1, it gives me the first part. 2 gives me the second part. What would happen if I did this? What would group 1 be? So group 1 is the same as before. It's 90210. What would group 2 be? So it doesn't exist at all. It's not an empty string, it's none. It didn't even find group 2, so it's giving me none. If I've got a dash, group 1 in this case is the same. What is group 2 here? Yeah, dash 4873. So capturing groups, they can be optional, but you get them captured regardless. It's either going to give you none or it's going to give you the actual capture, depending on whether it found them. Other questions? How can you know how many groups there are? Let's try that. So if we've got this M here, if I type groups, it gives me all of them. So that is one way you could know. You could ask for the length of this thing. It is a tuple, which works the same way as a list, but it's just immutable. You can't change it. So I have a sentence here. This sentence has airport codes in it. I can get the first one of these airport codes by doing the same thing we did before, matching an uppercase letter, 3 of these, surrounded by word boundaries. So search only gives us one thing back. If I wanted multiple things back, what could I do? Use what? Search whole. Search all. What do you think? That doesn't exist. There is something similar, though. I think you're thinking of find all. Before I show you find all, I want to show you something else, find iter. So find iter, this gives us a list of match objects. So if I get group, just like I did before, this gives us each of those matches. So it starts searching. Once it finds, it stops, gives you the match, and then starts up again from where it left off. So if I took this airport matches thing, and I converted it to a list, what type of things would be in this list, do you think? Would they be strings? So they are not strings. What are these? They are SRE match objects. So these are these strange match objects we've been working with. So find iter isn't much of a shorthand. This is the long form for getting match objects back. You still need to take those match objects and do something with them to grab a match out of them. So find all that you mentioned a moment ago, that does something slightly different. This is a shorthand. This gives us strings that represent each of the matches. Any questions about find iter or find all? Or capturing groups? No, it gives you the entire match object. So it's sort of like there's an implicit parentheses around the whole thing. It gives you the whole string that was matched. It's the same actually if we said group 0. Ooh, why didn't that work? So this is not something I'm going to talk about in this tutorial. This airport matches is a single-use object. So you can only loop over it one time. So yeah, group 0 there gives us the same thing as just group. Okay, so this find all thing here is pretty handy. When you want to find multiple things, you will mostly be using find all, not find iter. All right, let's say I have zip codes, and I want to find all of the zip codes in a string. What will this give me? How many matches will I get back, or how many strings? What about here? How many matches will I get back? Also 2. And here? Also 2. 2 that I probably shouldn't have got back because our regular expression is not all that great here. So I probably want to put word boundaries around this. That's at least somewhat helpful. But if we saw something like this, that's probably not a zip code we're dealing with, so still not all that great. How could I match the long form of zip codes as well as the short form here? Yeah, I'm going to do a group. Going to put a question mark. What do I put within it? How? 4 times. So this question mark here matches this 0 or 1 times. So how many matches is this going to give me back? Gave me 2, but those are not what I was looking for. What did it give me? What was in the parentheses? So it gave me -4873 and an empty string. So find all has a catch. When you use find all, if you use capturing groups, it gives you a tuple of all of the groups that were matched. Ooh, what happened here? Oops, I put that in between the backslash and the D. That's not allowed. So if we wanted a tuple of the optional dash part and the other part, we could use 2 sets of capturing groups there. So this is a little bit annoying. If we wanted to match this whole string and not capturing groups, find all doesn't allow us to do that. Ah, yeah, so like this. So we have parentheses with parentheses inside them and then another set of parentheses right after it. Is this valid? So it is actually valid. This does work. So what we get back, though, is a tuple with the entire match, the first part of the match and the second part of the match. So we would have to loop over this, grab the first thing, from each of these. So this is a little bit annoying and a little bit confusing. So there's another way to do this. This group here, groups are used for two things. What are the two things groups are used for? What are we wanting to use this second group for here? Why do I have a group at all? So this second group, I don't care about the fact that groups capture things here. The thing I'm using this group for is to modify to make it 0 or 1 times. I want this set of characters 0 or 1 times, so I'm modifying this group. I really don't care about the fact that this group is capturing. So we have to tell this group that it should be non-capturing. So we can write a non-capturing group here. Now the syntax I'm about to type is awful. I mean, regular expression syntax in general is a little bit hard to read. This is particularly hard to read. This is particularly hard to read because at some point in regular expressions history, they decided it would be nice to have non-capturing groups, but we have no way of doing that easily in the language without breaking some kind of backwards compatibility. We want existing regular expressions to keep working. So what we'll do is we'll introduce new syntax that would have previously been invalid and make it a valid syntax. So it would have been invalid to put a question mark after an opening parenthesis. So they put a question mark there, and then you put a colon. And it magically becomes a non-capturing group. So open parenthesis, question mark, colon is a non-capturing group. If you find that hard to read, it's because it is hard to read. This is, seeing a question mark after an open parenthesis means there is trouble going on. You have to go look in the documentation, see what the thing after that question mark means, and how it is modifying that group. So this is a case where you might want to turn on verbose mode and add some spaces in here to at least make things a little bit more readable, so that someone could see that this question mark, this colon, that parenthesis, those go together somehow. All right, any questions? So we're going to do another exercise break. We're at search exercises on the website. So if you go to the exercises page, you can scroll down to search exercises. Search.py contains these exercises as well. There are 6 of them. So I should have mentioned before, this last exercise break, you might have been able to get through all of them. In general, you should not be able to get through all the exercises in an exercise section. So do not get discouraged if you don't even get through one or if you only get through one, because these are meant for you to work through after this tutorial. I wanted to give you more exercises than you could get through. There's 30 of them. We have 3 hours, and I'm doing a lot of talking. So there's no way you're going to get through 10 every hour. Okay, I don't know when our break is. So we're going to do an exercise break right now, and then I'm going to figure out when that break is, and we're possibly going to take a half-an-hour break. Otherwise, we might just buy ourselves some more time. But if you have any questions at all, put up a red sticky, and David, Stephen, or I will come by and help you out. Questions about anything we went through, the exercises, or anything else? All right, we're going to combine the exercise break and the actual break. There is food outside at the moment, so feel free to go eat something, drink something, go use the bathroom, and we will reconvene. I'm planning on 3:10. Yes. 3:10. Any questions during the exercise break? Put up a red sticky. Happy to help. If you haven't taken your break yet, you have 2 minutes. So if you were working through the end of validation.py, you probably found some exercises that were really hard to do. It's because we haven't learned how to do them yet. Only the first few in validation.py have we learned how to do. We'll come back to that after this search section here. Right. Who would like to solve this first one together? Get extension. Cool. So search.py, there are also exercises in this file that are more advanced than we've learned how to do. This next exercise section, once we get to it, you're going to be flipping between validation and search. So you might actually want to get access to the website for this next section if you haven't already. All right, so get extension. So it is returning none. Why is it getting none? Yeah, we haven't returned anything. So the default return value for functions in Python is none. So we want to return something here. Let's import RE first, because we know we're going to need to use the RE module. What did you try to do here that didn't work? Didn't seem to work. Anyone try something out that didn't work for them the first time? So RE dot, search or find all? What should we try to use? Or find iter? Search? All right, what's the regular expression? What is a regular expression that doesn't work? All right, let's see. What's going on here? So we're getting match objects. How do we get a string from that match object? Group. So we can take the match object we get back, call the group method on it. All right, so we've got .zip, .xhtml, .jpeg, .tar, and we expected gz. How could we improve this? Remove the dot somehow? Yeah, how could we remove that dot? Parentheses around this, all right? Which group do I want? 1. So that's an improvement. So we got rid of XHTML, zip, and everything else there. We are failing at this one, though. So tar.gz Supposed to return GZ. How could I do this? $sign at the end here. Let's see what that does. Ah, there we go. So \w plus. Did anyone try something here that didn't work? Yeah, how did it get just the last one? Did anyone find extensions that were more than the last one? What did you end up typing that did that? A word break? A word boundary, rather? Let's see if that does it. So word boundary didn't do it. It says tar is not the same as GZ. So the reason a word boundary didn't do it is this would match the changing from R to dot, because dot is a non-word, R is a word. If we did word boundary $, that would work, but this is a little redundant because that $sign is already matching the end of the string. Yeah, a lot of you probably tried this word boundary here. Word boundary along with a caret or a $sign is an uncommon thing to see. Usually you use one anchor at a time. So what if I did dot here? Would that work? What would that match with archive.tar.gz? tar.gz? Yeah, why did it match tar.gz? So it finds a dot. It found the first dot. So regular expressions, by default, they are greedy. They are greedy. Not only are they greedy, they try to find well, they're greedy in two ways. They're greedy in the greediness way. That is something that the regular expression engine does. When you put an asterisk, a plus, a question mark, it attempts to do 0. If 0 doesn't work, it tries to go as far as it can. So it tries to match as many as it can, and then it backpedals if it has to. This is greedy in another way, though, in the sense that this period here, it's matching the very first one. So it's looking for, it's really lazy in this way, archive dot, finds the dot, and then we have dot period. Dot period matches what? One or more of any character. So it matches a T, an A, an R, a dot, a G, a Z, and then it sees the end of the string and goes, oh, that's fine. This matches just fine. So \w would fix this. Is there another way you could fix this? Did anyone find another solution to this one besides \w plus? Ah, so not dot. Anything but a dot. Yeah, that matches as well. So this is anything but a dot one or more times. So this works, this works. There's multiple ways to solve this one. In general, with regular expressions, there's not usually one right answer because there's a whole bunch of different edge cases that this would work differently on. Any questions? re.split, yeah, we haven't talked about that yet. So split, could we split on a period and maybe grab the last one? I think we could. In fact, I think we could just do that with plain old strings in Python. Let's try that real quick. Yeah, I think we could just grab the last one here. So actually all of these exercises, you do not need regular expressions to solve. Regular expressions are a tool, but they are not the only tool to solve these problems. They sometimes make things easier to read, sometimes not. This one, probably, honestly, I would probably use this to solve this. Split it based on period and grab the last one because it might be more readable. Or at least someone, a coworker probably, who doesn't understand regular expressions might have an easier time understanding what this does. And that's an unfortunate part about simple regular expressions. Often the simple regular expressions are the ones that you could equally solve a different way or another way. So re.split is. re.split's a little different though. Why did that split that way? So this is splitting on any character. I want to split on just dot. So if I'm splitting on just dot, this happens to not actually need a regular expression because strings have split as well. Strings do not accept regular expressions when you're splitting. If you needed to split on a regular expression, you could though. So when we see split, we'll see a couple cases where it's actually useful to use re.split, and in particular, and not just the string split. Inside of square brackets. Oh, interesting. Yeah, that is one way to do it. So that would be splitting on any number of a set of characters, which you can't do with the built-in split to Python, but you can do with re.split. Yeah, but re.split actually can be used for a whole bunch of things. Anything you can think of a regular expression for to split on, you can use re.split for. What does this match? That regular expression, what is that describing? Time? Could be. A range? Literally, what is it describing? 2 digits, a colon, 2 digits. So this could be time. This could be some sort of range of some sort. Could be something else. We're going to match time. We're going to match 24-hour time. Is this a valid time? That is not a valid time. We are matching that. How could we attempt to, well, actually, is this a valid time here? 2360? That's not a valid time either. So minutes should be 00 to 59. Hours should be 00 to 23. Okay, how could we restrict minutes to stop at 59? How could we make this not match? Zero to 5. So instead of \d, use 0 to 5 and then a \d. So that doesn't match. This does. That does. Will 59 match here? Yeah, that second digit is still matching the same way it was before. Just that first digit we changed. All right, what about this 24? How could I make 24 not match? So this one's a little trickier. How could I make 30 not match? What could I do? Right, so 0 to 2 here would make 30 not match, whereas 0, 0 still matches, 23 still matches. We still have the problem of 24, though. So at this point, we have to use something we haven't talked about yet. The reason we have to use something we haven't talked about yet is we've got a fork of sorts. We need some kind of condition to say, if we have 0 or 1, we want to match any digit afterwards. If we've got a 2, it can only validly be a 1, a 2, or a 3. We can't have anything after that. So regular expressions are not well suited for this problem in general because we're working with numbers. We're not working with characters here. We're working with numerals. And regular expressions have no notion of numerals. They only understand characters. If we were to write a regular expression to do this, though, we could do so by making this a 0 or a 1, adding a group, and using a pipe. What does pipe do? Or. So this is 0 or 1, any digit, or, what would the other thing I'd type here be? A 2, and what would the second digit represent? 0 to 3. So this is 0 or 1 at any digit, or a 2 with a 0, 1, 2, or 3 after it. So 24 doesn't match. 23 does. 18 does. So does 10. So this pipe here is an OR. This is allowing us to alternate between one of two things. Yeah, so the problem here is if we did 0 to 2, we want a different behavior for 2 and for 0, and we can't put a \d inside here because the character class matches a single character. So that's a good point, though. You're on the right track here in the sense that character classes, they're used for alternation. They're used for alternating a single character. Whereas this pipe here, this is used for alternating between any number of characters. You can type any sub-regular expression, a pipe, and then some other sub-regular expression. Whereas in a character class, it's essentially a shorthand for using this pipe. So this 0, 1 and this 0, 3, this is kind of like I typed 0 or 1 or 2 or 3, which is a really weird thing to see because we have this character class that allows us to do this or make a range like this. So character classes are the character-based alternator. This pipe here is the whole regular expression, multiple characters at once based alternation. Other questions? All right, so that's pipes. Let's talk about that split that you mentioned earlier. What will this give me? How many things? So we are splitting on comma. It gives me 3 things. This second one starts with a space. Why does it start with a space? Yeah, I've got a space after the comma. So I'm splitting on comma. I'd like to be splitting on comma and any number of spaces afterwards. So we could attempt to write a match, a find all, like this. How many things is this going to give me back? I'm looking for any number of characters, a comma, and any number of spaces. What do you think? So it gives me 1 here. Why does it give me 1? So this period here, it is matching that comma. So I could say not comma any number of times, comma any number of spaces. I only get 2 here. Why don't I get the third one? Yeah, well, actually, it's because I don't even have a comma. So column 3 here, it doesn't end with a comma. So if I said A comma B, it only gives me A. If I put a comma after B, it gives me B. So I'm really not splitting here. This isn't a split, this is a find all. So I could say comma any number of spaces or the end of the string. This is getting a little complicated at this point, though, and in fact, that find all is giving us more than we want. So sometimes it can be convenient to not model your search as a regular expression search, but as a split. So that re.split, if you think of the world in terms of splitting, you could instead say, what here? What could we split on? A comma and what? Or would just comma work? So we've still got a space there with comma. How many spaces do I want after that comma? 0 or more. So I'm going to say white space characters, 0 or more of those. So I'm splitting using a regular expression. So if you find yourself using the string split built into Python strings, and you'd like to use a regular expression with it, reach for re.split. If you're using a regular expression and you realize this problem is well suited for splitting and not for finding, use split instead of find all. All right, any questions about split? So I want to mention real quick here that there is built into the regular expression module a compile. The thing it gives me back is a compiled regular expression, which conveniently has on it search, split, and other features that are built into the regular expression module. So it doesn't make sense for us to split here. It makes sense for us to search. We might want to find all, we might want to split, we might want to search. It really depends on the regular expression we're writing. Compile is a way to write a regular expression one time and use it many times throughout your program. You could just write a string and use it many times throughout your program. This goes a little bit beyond that and actually does the work of compiling that regular expression and optimizing it so that it'll search faster. So I want to mention compile there. You don't have to use this during the exercises, but I do want to show you that it exists because this, especially when you're using verbose mode, it's a very common thing to write a regular expression one time in one place, comment it well, give it a variable name, and start using it throughout your code. All right, I have a quote here. I have a quote, and this regular expression is looking for double quotes, any number of characters, double quote. What is this going to match? How many things will we get back, if any? Who thinks we'll get nothing, no matches at all here? Who thinks we're going to get one match? Who thinks two? Who thinks something else? All right, so we get one match. We get what you'd expect here. How many matches do you think we'll get here? Who thinks we'll get 0 matches this time? Who thinks we'll get 1 match? Who thinks we'll get 2 matches? 3? 4 matches? So we get an error. Why do we get an error? I typed a single quote inside of a single quote. I could backslash that. Instead, I'm going to make this triple quotes. That didn't work. Yeah, I'm just going to add a period to fix that. So we got a single thing matched there. In fact, I'm using search instead of find all. I meant to be using find all here. Why did we get a single match? Yeah, what is dot match? Everything. So dot asterisk, this is matching any number of characters. It goes all the way to the end, and then it backspaces until it finds, oh, there's a quote here, just after the W and before the period. So there are double quotes inside of here. So I could fix this by saying not double quote. And I get 2 matches there. That might be one way for me to fix that. Okay, so there's another way to fix this. This here is a little bit hard to read. Also hard to read, but maybe a little bit more clear sometimes, is this. What does question mark normally do? What has question mark done so far when we've seen it? Yeah, it matches the thing before it 0 or 1 times. So it modifies the thing before it. It is not modifying the thing before it here. The asterisk is modifying the thing before it. This asterisk is saying match the thing before me 0 or more times. This question mark is modifying the asterisk and making it non-greedy. So regular expressions by default are greedy, meaning when they see an asterisk, they're trying 0, then when they don't match 0, they go as far as they can, matching as much as possible. Non-greedy regular expressions try to match as little as possible. They're conservative. They make the shortest string they possibly could that ends in a double quote. So this question mark here is telling that asterisk, I want you to be a non-greedy asterisk. Now, it's probably confusing that there's a question mark after an asterisk. More confusing is you can put a question mark after a question mark. Let's take a look at these. So we can say this. What is this going to match? How many eyes will this match? 3 eyes. So it's matching all 3. How many eyes will this match? 1 eye. And this one? 3 eyes. What about this? All 3. What about this? 2. So it's going as far as it can. All of these are greedy. All right, let's do this. Asterisk, question mark. How many do you think this will match? So it matched 3 before. This time it matches 0. It's as short as it can go. What about question mark, question mark? How many will this match? None. No eyes at all. Plus question mark. How many? 1. So 1 or more, that question mark is making it non-greedy. All right, let's do 2 like this. How many will that match? 2. That is the shortest it can go. And 1, 2. What do you think? Yeah, just 1. So in general, you do not need to know about greediness. It is rare that you absolutely have to use greediness with a regular expression. Usually, you can get around needing greediness by writing something like this. Not, double quotes, not the thing I'm trying to match, to make something not non-greedy, but match precisely what you're looking for. There are times this isn't good enough. There are times where you can't get away with simply negating something and matching less. You can often negate something and match less. When you can't, remember greediness. Remember greediness, go look up how to make something non-greedy, look up the cheat sheet, put a question mark afterwards. In general, turning off greediness, making something non-greedy makes your regular expression harder to read, so avoid using non-greedy regular expressions unless you need to, or non-greedy matching, rather. All right, so we have more exercises now. It looks like we actually might get to the last exercise break because we're doing pretty well on time. These ones are just called more regular expression exercises. On the website, you will see the actual things that we're working through. It's isNumber, which is in validation, abbreviate, which is in search, is hex color, which again is in validation, and is validate, which is in validation. So the reason I've alternated these between sections is because I wanted to confuse you. Now, I didn't actually want to confuse you. I did confuse you, but I alternated these because when you are working through exercises, when you're getting practice at something new, it is a good idea to interleave multiple topics at once. If you just work on validation exercises and then you go to search exercises, you will get better at validation exercises, but you're fooling yourself because you're getting better at validation exercises knowing that's the task that you're trying to solve. Typically, when you're writing a regular expression, you don't know what it is that you're exactly trying to do. It's difficult to write a regular expression unless you have context. And with context, you're cheating yourself a little bit because usually you're lacking that context. So after this tutorial, you're not going to get through all these exercises. I would recommend you stripe the ones you're working through. You interleave different types of exercises next to each other. If you have any questions at all during the exercise break, put up a red sticky, whether about the material, exercises, or anything else. you get stuck on any of these, don't be afraid to put up a red sticky. I'm going to give you a little over 5 more minutes. All right, let's work through this first one together. So is number. None is not true. So I'm getting none because that's a default return value for functions in Python. I have the RE module imported. So I want to return a Boolean, whether or not this is true. So the regular expression I'm writing here should be validating whether or not this is a number. Okay, what did you start with that didn't work but it got you in the direction? Dash question mark slash D. Oh, backslash D. Asterisk. Okay, so this here is what? Zero or one dashes, so optional dash there. This is 0 or more digits, and then what? Slash dot. So why not just a dot? Yeah, this is a meta character. So we've got a literal period there. Another way to write that would be this. Either of those works. And then what? Asterisk? Dollar sign. So dollar sign there would be 0 or 1. I'm going to put an asterisk here. So this doesn't work. We've got negative. So with a period, ooh, this is actually saying true. So this is saying true. Why is it matching negative 123.859 point? Yeah, this is a substring. How can I make this match the whole string? Caret and dollar sign. So this is only a string that exactly matches this thing. All right, we still have a problem. So period is a number. That's an issue. 5 is not a number. That's an issue. Those are only two failing. So how can we make 5 into a number? Make this one optional. Put a pipe. Could I put a question mark here? Let's see. So that worked for 5. It did not help us at all for this period. So that's one way to do it. I think we could have used a pipe there as well. Okay, so period. How do we make period and not a number? Parentheses, where's the opening parenthesis go? Like that? Let's see. Still doesn't work. Why doesn't it work? So why does period match here? Everything else is optional. So we have an optional hyphen, 0 or more digits, 0 or more digits. What if we required one of these to be 1 or more? All right, so that failed. That failed because 0.5 apparently is supposed to be a valid number. So let's try the other way. All right, 5 points supposed to be a valid number too. So we need 5 point and 0.5, but we don't want just point. Did anyone find an answer for this one that seemed to work? What'd you do? Okay. That's where the pipe is. So basically the same thing we just did here, where one of these was a plus, which worked except it failed for the 0.5 case. So you had this, or, and then what was on the other side of your pipe? All right. So that worked. I think that actually fails for one case that I'm not testing. What would that fail for? So my tests, your tests are only, or rather your code, when you are practicing TDD, your test is only as good as the creator of the tests. And I failed to write some tests here. The test that I failed to write that I can think of here, yeah, minus .5. So if we move this minus sign to the outside, minus .5 would work. But I didn't test for that, so this is a valid, successfully passes the test here. But yeah, this pipe here, this is a way for us to handle the issue of having one or more digits before and one or more after. In fact, this also fails if we had any digits before the period. However, that doesn't matter. That doesn't matter because if we have any digits before the period, this one will match. So there are multiple ways to write this one. You could do it this way, you could do it this way. Either of those pass, and they both match the same thing. Any questions about alternation or anything else? The abbreviate one? Yeah, that one's a tricky one. So abbreviate, I'm not going to do abbreviate. I will say that abbreviate, one thing you could look for is spaces, or rather word breaks. You could look for word boundaries, so that backslash be a word boundary looking for a letter that has a non-word before it or the beginning of the string. That's not going to work for that case of JavaScript though, because J and S are both part of JSON, JavaScript object notation. And so you're probably going to need a pipe to say either we're looking for word boundary capital, or word boundary any letter, or a lowercase letter and then a capital letter that we're grabbing there. It's going to be difficult to write that pipe and actually capture it. Yeah, if you want to look through the answers of any of them in particular together, feel free to stay after. There is material we're probably not going to get through. Actually, did anyone come to this tutorial specifically because you wanted to know how look-aheads and look-behinds worked? Okay, good. We're going to skip over that. That's at the end. That is something you hopefully will never need to do, because it's painful and ugly looking, and it makes your regular expressions harder for everyone else to read. You usually don't need to actually rely on look-aheads and look-behinds. It's a very rare time that you really need them. Usually you can get away without them. So there is material on that at the very end. Feel free to go through it and send me an email if you have questions about anything. I think you all have my email address at this point, right? I think I've sent you an email. If you have questions about anything after the tutorial, feel free to ask. If you didn't ask during, feel free to stay after for a bit and ask me questions either about abbreviate or other exercises as well. Let's talk about substitutions. Has anyone ever used LaTeX before? LaTeX? So I use LaTeX sometimes, and LaTeX wants you to use smart quotes, meaning 2 backticks and 2 single quotes in order to actually make smart double quotes that turn into smart quotes using Unicode smart quote characters. So we could replace these and change them to simple double quotes using Python like this. Replace the backticks and replace the single double quotes. That works. We could also use a regular expression for this. So in the RE module, there's a sub. What does sub stand for? Substitution. So we can do backtick, pipe, single quote, substitute that, and what am I going to replace that with? So I'm going to replace that with a single double quote character there, a double quote character. So that does the same thing, it accomplishes the same task. So re.sub is useful for a number of things. One of the things that it's particularly useful for is data normalization. So for example, we have this row. What were we splitting this row on before? Yeah, commas and any number of spaces. Normally, if you're parsing a CSV file, you don't care about spaces. It cares about commas. So if we wanted to take this and make it into more of a CSV typical format, we could convert comma and any number of spaces to just comma. So we could say re.sub, comma and any number of spaces, replace that with a single comma. And that space was removed there. Would this have done anything different if I used a plus there? So we get the same string back. The reason we get the same string is that commas that don't have a space after them weren't replaced because they were already what we were looking for. So either of these works just fine. All right, so substitutions. This is pretty much the third tier of what we're looking at here today. We've done validation, we've done searching, and now we're doing substituting, mostly for the purpose of normalizing data. Or not just normalizing data, but also changing the format of data. So for example, we have dates. What format are these dates in? Month, day, year. So these are US style dates. If we're sending this string here to someone who is from pretty much anywhere else in the world, they might be confused. They might expect day, month, year. We could make this unambiguous by using year, month, day, by using an international format. So I'm going to substitute here. What am I going to match? So I want a digit. How many digits do I want? 2. Then what do I want? A slash. And then 2 more digits. A slash and 4 more digits. So substituting here, I've got an issue. I need to somehow capture the year, the month, and the day and use those in my substitution. So when normalizing data, this isn't always just about taking commas and spaces and replacing those with just commas. Sometimes you don't know what it is you're actually substituting. We're matching any digits. So we talked about groups before. What 2 things can groups be used for? Matching a value. So grabbing, capturing something for use later. Yep, you can use them for capturing. What other thing can groups be used for? Yeah, well, so that, I was considering that capturing. The other thing they used for, which maybe was what you're saying first, is taking a group and modifying it to do any number of times. So making it asterisk, question mark, taking one of our quantifiers and modifying our group. So we can use them for modifying, which is not what we're doing here. We're going to use these for the other behavior, capturing. So we're going to grab that first thing. What does that first thing represent? Month. Second one's day. Third one is year. So I want to do the third one first. I want year, and then month, which is the first one, and then day, which is the second one. So I can use backslash and then the number of the group in my substitution. So group with a number, that number can also be used when substituting. Any questions about this? Right. Yeah. Yeah. So I am not adding new text here. I am taking existing text and substituting it with parts of itself. I'm taking 3 of the parts of this text, basically removing the slashes and rearranging it, adding dashes instead. But yeah, I am not really normalizing, or rather I am normalizing this, but I'm not replacing anything with anything novel or new. So you can use substitutions or substituting both for the case of taking something like commas and a number of spaces, replacing them with commas, or taking data and replacing it with parts of itself. Other questions? So we can actually use these / number things. These are called back references. We can use that, well, there's multiple names for them. Back references is one of them. We can use these in not just substitutions, we can also use these when searching. So I want to show you an example of this. For example, earlier we talked about looking for quotes. So here we're looking for a double quote or a single quote. Any string in a non-greedy fashion, and then a double quote or a single quote. So this gives me not really. That gives me y and, ooh, what's going on there? Why does it give me I dawn? So I'm looking for single quotes or double quotes. I am not making sure the end quote matches the beginning quote. If I put this in a capture group, I could use a back reference here. What back reference would I use if I wanted to match the same quote? \1 or 2? \1. Oh, that gave us something interesting. Why did find all give us this? So what does find all give you when you have capturing groups? Gives you a tuple of all of the groups. So we don't actually care about this group. Could I make this non-capturing like we did before? What do you think? That did not do what we wanted. What is that doing? So there's a problem here. The problem is back references rely on the capturing nature of groups. When I make a group non-capturing, it's trying to look for exactly the same quote, because that :: makes the group non-capturing, so the first capturing group is the second group that we wrote there. So we have to have this group capturing, but find all doesn't give us what we're looking for if it is capturing. So there's not really an easy way out of this. One way would be to use find iter and fall back to doing this manually. You'd say for im and find iter, print im.group. Which group would it be that I care about? So group 1 is the quote that we used. Group 2 is the actual quotation. So on the website, there's a couple other solutions for working with this situation. When your find all has to use capturing groups, You can use a list comprehension, you could use findItter, you can use findAll, you can even use zip sometimes. There's not really a great solution to this problem. Sometimes regular expressions are not the most elegant tool to solve your problem. In fact, probably most of the time, when you think you should use a regular expression, you shouldn't. That's maybe the second takeaway from this tutorial. Stop using regular expressions so much. They are very useful, and it's nice to know cases where regular expressions can be used, but they are not always the best tool to solve your problems. If you are using them, remember to turn on verbose mode, though. Okay, so we have another exercise section. If you have any questions at all, if you found what I just did confusing, feel free to put up a red sticky. Happy to either talk through an exercise with you if you get stuck somewhere and just want a little bit of help, or work through one of the exercises in some other way or answer a question. So we're in capture exercises on the website. We are mostly at the end of the search module. Actually, all three of these exercises are in the search module. We're working through palindrome 5, double, and repeaters. So any questions at all, put up a red sticky. All right, let's try to solve this first one together. Palindrome 5. So this is supposed to find all 5-letter palindromes in a given string. All right, how could we use a regular expression to get a list of matches? What would we use from the RE module? RE dot what? What could we use? Does search give us a list? Find all? So search gives us a single match object. Find all would give us a list of strings. Could also use find iter and iterate through it and get strings out of it. We're going to try to use find all though. So we're going to make a regular expression and we're matching on our dictionary that is passed into our function. All right, so now we need to write a regular expression. 5-letter palindrome. So I'm going to just say all words with 5 letters. Ooh, this matched APU. Why did it match APU? Space AP, A space PU. That's not a word. Yes. Got a dot. All right, let's make that W. It also matched PULLU. Why did it match that? And race C. Would this work? So this doesn't work. This limits it too much. Why did this not work? What does caret do? It's actually the beginning of the string here. Yeah, so caret and question mark are the two things we've seen so far. Well, question mark 3 uses of question mark, non-capturing groups, non-greediness, and 0, 1. This caret here outside of a character class at the beginning of the string, this matches the beginning of the string. What does the $sign match? The end of the string. So we're matching the beginning and end of the string. We do not want that. What do we want to match? What anchor? Boundary, a word boundary. So we want to match 5 word characters on their own. So there should be spaces around them or dashes or some kind of word boundary, or the end of the string or the beginning of the string. Okay, now let's make this into a palindrome. How could we look for a palindrome? What is a palindrome? Yeah, it's the same word backwards and forwards. What could we do for 5-letter palindromes? So put this in parentheses. Okay. Why 2 and 1 and not 1 and 2? Yeah, it should be flipped. So the last letter should be the same as the first. The second to last should be the same as the second. Oh, that's weird. What is it giving me here? LE is not level. ST is not stats. So this is a problem with find all. You could have used find iter here and looped through these and grabbed exactly what you wanted out of it, group 0. You could have also surrounded this all in parentheses. Oh, that didn't work. If we surrounded it all in parentheses, we've got to bump these up. It changes the numbers. So now we get level LE, stats ST, still not what we're looking for. How can I get rid of the LE and the ST? Could I make them non-capturing? No, why couldn't I make them non-capturing? We need them. The 1 and the 2 rely on the fact that they're capturing. So I'm going to use find iter for this. I'm going to say matches equals this, and I'm going to use a list comprehension here. You can use a for loop just the same. m.group for m in matches. So we're grabbing the entire match from each of these. As a for loop, this would be for m in matches. Just make some variable here. So equally valid as a for loop, but the list comprehension is a little bit shorter. All right, any questions so far? Do we have to use find iter? We could use find all. Did anyone use find all for this one and get it to work? So if you used find all, you'd have to surround everything inside of parentheses. And that changes the numbers here. So we'd have to do 2 and 3. And then matches would be tuples. And I think it's the first one we'd want out of this. See if that works. Yeah, that works as well. I think this is a little bit more confusing personally. I think at this point it's probably best to fall back to using find iter because match objects are a little bit easier to work with than these awkward tuples. Other questions? So we are approaching the end of our time together here. We have 2 more exercise sections. One of them is on look-aheads, though, and you can skip over that if you'd like. The other one I would encourage you to look at after this tutorial is over here. I do want to mention real quick the material that leads up to that section, which some of it is non-essential but can be valuable for solving those exercises. So we've talked about groups. We've talked about back references. \1 gives you the first capturing group. \2 gives you the second. You can also use this weird question mark thing here in your groups, and a P, an open bracket, a less than sign rather, a name, and then a close bracket to give a name to your group. And then your groups can be referred to using these back reference G year, back reference G month, back reference G day. This makes things easier to understand in a sense, but also harder to read in a sense. If you are using these, I would recommend using verbose mode. If you've ever used Django's URLs, you may have seen these occasionally mentioned in documentation or in code. So these are named capturing groups. You can look up named capturing groups on your own, know that they exist and that they can be handy. They're really not essential. They are a handy tool to have in your tool chain, though. The other thing I want to mention has to do not with capturing groups, but with substitutions. Any questions about this? So this one's quite a complicated one. This is a function, replace date, that takes a match object, takes the groups out of it, month, day, and year, checks to see if the year is 4 digits long. If it is, it uses that year. If it's not, it does some logic to figure out whether it's probably a 19 year or a 2000 year, and then returns a year. So it tries to convert 2-digit years to 4-digit years using some complex logic here, which we really couldn't do easily in a regular expression. You can use a regular expression. I'm using compile here, but you don't have to use compile. You could use sub with a function. So I've used sub so far with a string. You can use it with a function as well. So I'm going to write this as well without using compile. re.sub, our regular expression, our replace date function, and our sentence. So if you are having a lot of trouble figuring out how to write your substitution to actually do what you want, you can always fall back to using a Python function. It's a little bit hard or a little bit complex sometimes because your function has to take in a match object and return a string, but it is a nice thing to know that you can do because you can't do everything with regular expressions. It is nice to be able to fall back to Python code. So substitution exercise is the next thing that we would be working through here. We only have 2 minutes left, so I'm going to wrap it up at this point. Any final questions at this point? Any questions about regular expressions in general that you feel like we didn't get answered? If so, feel free to stay after and talk to me personally about it. I do want to mention real quick, I didn't really do an introduction to myself at all. My name's Trey. Hi, nice to meet you. I do Python and Django training, so I do this kind of stuff for a living. I don't teach regular expressions usually for a living. Don't think of me as a regular expressions person. I don't want to be pigeonholed in that way. I don't like these nearly as much as you might think I do. I teach these because I learned regular expressions from the Perl world, not knowing at the time that they were a weird thing in most programming languages. Then coming to Python took some of that baggage with me. They are useful in Python. They are not the end-all be-all. I do want to mention, outside of doing training, I also do a live chat every week. A live chat on Python called weeklypython.chat. I have done a video on regular expressions before, which is pretty much the same content as here. If you have any questions about Python, I love doing videos on these things. I love writing blog posts on these, so feel free to ask me afterwards if you'd like to see me do a video on something in particular. In general, I appreciate emails. If you have an email with a question about Python or regular expressions, do not be afraid to email me or approach me in the hallway and talk to me. I am an introvert, so if I see you in the hallway, I may or may not talk to you, but don't be afraid to, come up and talk to me and ask me a question about pretty much anything. If you have any questions, or if there was anything after this that you feel like really didn't get answered, please let me know, because I'd love to add that to my curriculum next year. It won't help you out because you just finished this tutorial. Maybe I can point you to some resources that might be particularly handy, though. I should probably put up again that survey link. I actually am not convinced that this is the survey for this tutorial because it mentions things about the morning and not the afternoon. So you might be filling out a survey for someone else's tutorial. But that is not my problem at this point because this is the only URL that I have. I think this is the right tutorial or the right URL, but if it isn't, let me know and I can ask someone if there's another one. Or maybe it asks you which tutorial you went through. I actually haven't been to that URL. It has the name at the top? Excellent. It's the right link. Good to know. So yeah, you can go there and fill out a survey that I believe the program committee wants people to fill out surveys to find out how the tutorials went. So I'm going to stick around for a couple minutes afterwards. We might be shifted into the hallway, but feel free to ask me questions regardless. Thanks a lot.